Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam. Whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one simple circle question lost more marks than any other on last year's exam, not because the maths was hard, but because students didn't show their angle chase. Do you remember writing a final angle with no explanation and getting half the marks taken away? If that sounds familiar, stick with me for the next 11 minutes.
That happened to me. I had the right final number, but lost marks because I didn't write the steps.
Promise and roadmap. In the next 11 minutes, I'll teach you one reliable angle chase routine that beats memorizing a list of named theorems. We'll 1. Build the routine step by step. 2. Work through an AQA-style example together. 3. Show exactly where the marks come from. And 4. Finish with a quick win you can use in every practice paper. Let's work through this step by step. The concept, start with the routine. There are 4 simple, repeatable steps you can use on almost any circle question. I'll say them first, then explain why each one matters. Identify the key arc or chord. Pick the easiest angle to find. Link that angle to a theorem. Write the relationship as an equation and solve. Repeat after me. Identify, pick, link, write. Let that sink in.
Step 1. Identify the key arc or chord. Look at the diagram and ask, which arc or chord connects the angles I can see? Circles are about relationships. If 2 angles subtend the same arc, they are equal. If an angle subtends the whole arc at the centre, it's double the angle at the circumference. Spotting the arc gives you the bridge between angles. So instead of thinking of theorems as separate rules, I should look for the arc that ties the diagram together.
Exactly. Step 2. Pick the easiest angle to find. Often you can find a right angle or a simple triangle angle using the sum of angles in a triangle or a straight line. Start with the one that requires the fewest steps. This gives you a foothold, a known quantity to anchor the rest of your chase.
Step 3. Link that angle to a theorem. Use the named relationships only as connectors. Angle in the same segment, angle at the centre is twice the angle at the circumference, angle between tangent and chord equals the opposite angle in the alternate segment. Cyclic quadrilateral opposite angles sum to 180 degrees. But you don't need to recite them. Show how an angle you know maps onto the one you want. Step 4. Write the relationship as an equation and solve. Always label the angle with a letter. Let angle A be x, angle B be y. Then write x equals y, or 2x equals y, or x plus y equals 180, whichever the link gives you. The examiner wants to see that equation. That's method marks waiting to be claimed. Write it down. Don't just think it. Why this routine works, it forces structure. Instead of jumping around a diagram, you build a chain of small, verifiable steps. Each step is short, and the examiner can tick a method mark for it, even if your algebra slips later. Marks are there for the taking.
Could we try it on a real example? I learn better by doing.
Absolutely. Worked example. Picture a circle with centre O. Points A and B are on the circle, and tangent at B touches the circle. Angle between tangent at B and chord BA is given as 40 degrees. There's another angle at the circumference that subtends arc AB at point C, and you are asked to find angle ACB. Let's apply the routine. Identify, pick, link, write. Identify the key arc or chord. Arc AB is the connecting arc. The tangent at B and the angle at C both relate to arc AB. Pick the easiest angle. The 40-degree angle between the tangent and chord BA is our known quantity. Link that angle to the theorem. The angle between a tangent and a chord equals the angle in the opposite arc at the circumference. Therefore, angle ACB equals 40 degrees. Write it down. Angle ACB equals 40 degrees.
That was much quicker than I expected. So you used the tangent chord theorem to jump straight to the angle at C?
Yes, and crucially, each step is written. On an exam, you'd write angle between tangent and chord equals angle in opposite segment. Given equals 40 degrees, therefore angle ACB equals 40 degrees. That gives you M1 for stating the theorem and M1 for applying it, then A1 for the correct answer. Even if you miswrite the number at the end, those two method marks are likely to stick.
Let's take a slightly harder variant. Suppose the angle at the centre, angle AOB, is 120 degrees, and you need angle ACB at the circumference. Identify the arc AB. Pick the easiest known angle, angle AOB equals 120. Link using the angle at centre is twice the angle at circumference theorem. Write 2 times angle ACB equals 120. Solve angle ACB equals 6 degrees. Again, label and write the equation. That's your method laid bare.
So for that one, you'd write something like angle at centre AOB equals 120 degrees. Angle at centre equals 2 times angle at circumference. So 2x equals 120, x equals 60. And the examiner can award method marks even before I write the final number.
Exactly. Now the exam technique section. How marks are awarded on circle theorem questions. Most higher tier geometry questions use a combination of M marks for method and A marks for accuracy. Typical breakdown: M1 for a clear statement or labelling, M1 for a correct relationship or equation, A1 for the correct numerical answer. If there's algebra, you might see M1, M1, A1, A1 depending on the complexity. Write intermediate steps so the examiner can follow you.
Common examiner traps: not labelling angles, assuming facts without justification, and skipping equations. For example, writing x equals 60 with no justification will often lose the first M1. Another trap is poor notation, mixing up angle labels or reusing the same letter for different angles. A little tidy labelling saves marks.
What if I'm unsure of the final numerical answer? Can I still get method marks?
Yes, that's the quick win. Use a notation trick to capture method marks even when you're unsure. Start every circle theorem answer like this. Let angle ACB equals x. Then write the clear relationships you see. Angle between tangent and chord equals angle ACB, so x equals 40, or 2x equals 120. Even if you make an arithmetic slip later, those labelled equations show the examiner your method. Write it down, don't just think it.
A second quick win: use small brackets to show substitution. If you find angle B equals 50 and later use it, write angle B equals 50. Then when substituting, write angle B plus x equals 180. That clarity makes it trivial for the examiner to award M marks.
I always forget to label. From now on, let angle equals x will be my new habit.
Practice prompt and recap. Try these now, 1 for 5 minutes each. 1. A tangent at P makes 30 degrees with chord PQ. Find angle in the opposite segment. 2. Angle at centre subtending arc RS is 140 degrees. Find the angle at the circumference subtending the same arc. 3. A cyclic quadrilateral has one angle 70 degrees and another adjacent angle 50 degrees. Find the remaining angles. Use the routine. Identify, pick, link, write.
One sentence recap. Identify the connecting arc, choose the easiest angle, link using a theorem, and write the relationship as an equation. That sequence wins marks every time. Marks are there for the taking.
That's your quick win for today. If this helped, share it with a friend who's revising. You'll find more work solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.